Okay, so welcome to Text Issues, guys. Here's the video in which we are going to talk about the first phase of CEH, certified hacking. Okay, and this phase is about the reconnaissance. So reconnaissance is always the first phase of hacking. And what is basically that means? Simply means we have to gather the information in this phase, okay, as much as possible, and yeah, it must be confidential and true. Okay, so yeah, it's a very important part because in real life also, if I want to attack someone, so obviously I have to gather information first, so that in the meanwhile it won't be get obviously if you don't have any plan and plan built on behalf of the information, okay, so definitely you need the information. So for the testing also, whenever if you want to do some testing on some application, so yeah, you have to get the information first. Okay, so what we are going to do, we are going to first find out the informations, and there are some things that we are going to cover up in this one, okay, and don't worry, apart from these things, much more we are going to cover up. Okay, so reconnaissance simply means information gathering, and basically that reconnaissance is divided into two categories. One is the footprinting, as you see in this thing. Okay, let me just type it here. One is footprinting and another one is the fingerprinting. Okay, here's the finger. Okay, just type the wrong spelling. And another one is the fingerprinting, and fingerprinting is all about the OS detection. Okay, not the other information. We just only detect the operating system in the fingerprinting. So reconnaissance divides into two categories. One is the fingerprinting and the one is the footprinting. Fingerprinting simply means OS detections, and footprinting means apart from the OS, whatever the extra information, like ranges, subdomains, some official address, some other sensitive informations like emails, okay, servers, and all those stuff. Okay, so yeah, we are going to see in the footprinting. Okay, let's start. So the first thing we are going to do is called a fingerprinting, and in the fingerprinting we are going to see these things, because with these things you can detect the operating system of the victim. Okay, the first thing we are going to cover up is called the TTL value. Okay, so here's the TTL. So with the help of TTL you can detect the operating system of the victim. And what is TTL exactly means? It simply stands for time to live. Okay, so now from which utility or from which tool you can see the TTL. Okay, so there are the different ones, but right now I'm going to use a very basic one, which is called the ping. Ping is a utility, and most of the operating system have ping. So whenever type google.com, so see, so it's doing some things like the first one is called the request from your side. The next one is called the reply from the server side, and alternatively it goes on and on until you just stop this thing. So the first one is the request, second one is the reply. You can see this thing if you capture all this stuff in your Wireshark. Okay, so then Wireshark will get to know, from the Wireshark will get to know that it's one is the request and other one is the reply from the server. Okay, now here it is showing you some information. Okay, for the better understanding, let me just okay, here's the Windows 7. Okay, now see, meanwhile it's running, just tell you the meaning of this thing. Okay, so let's start one by one. What are these things? So the first information this ping is giving to me is the IPv4, stands for IP version 4. The server name ICMP sequential, because whenever you do ping, so the ICMP packet goes. Okay, ICMP, so it depends on the type of scan also, but if you are doing the ping, so simply means you are sending the ICMP packet, okay, to communicate to that particular victim. Time stands for the timestamp, means a loop in between from the client side machine to reach to the server and then come back to you. So it's a loop. Okay, so that thing is called a timestamp, that how much time it would take from the request which goes from your machine to the server machines, then come back to you. So it's a whole loop, and this thing is called timestamp, like how much time it would take. So firstly it would take 3.7.34. Okay, now Okay, so here's this machine. Let me check the IP of this machine. So IP of this thing is 0.100. Okay, so let's try to ping this machine. 68.0.100. Okay, now see, as I told you, with the help of the TTL you can detect the operating system. Now see why. You know, most of even hardware, most of the operating system have fixed TTL values. Like if you search on the Google, like list of the TTL values for the operating system and for the hardware, then Google shows you result like for the Linux it is 64, for Windows it is 128, for Mac it is 255, and even for the hardware also. Okay, so on behalf of that list, so as I told you, okay, let me show you the I'm just writing the primary one. So okay, so for the primary one, for like OS, the TTL, and for Windows the TTL value is 128. For Linux it is 64. For Mac it is 255, and even for the hardware. So these are the primary one. Okay, these are the primary ones. So just keep this thing in your mind. Now see. Okay, so see, when I ping this machine, it shows me the TTL value 128, and 128 stands for the Windows. Okay, and yeah, it is the 100, and 100 is the IP of this machine, and yeah, it is Windows. Okay, but when I ping this thing, let's say this one, ping space google.com, so it simply means that maybe Google deploy on a Linux based machine, because this 56 is close to which one? So this 56 is close to the 64, so that's why it's just Linux. Okay, that maybe the server deploy the Linux. Okay, but the question here is why it is not showing 64 instead of it is showing us the 56. So why? Okay, to understand this thing, there is a concept behind this thing which is called, okay, let's understand why it is not showing 64 instead of 64, it is showing 56. So the reason behind this thing is that TTL, first understand what is TTL. Actually TTL is the notification of a packet to check whether the packet is not in a loop. Okay, so let's take an example. These are the routers. Okay, and router 2, router 3, and router 4. So TTL is just a notification of packet to check whether the packet is not in a loop. Suppose there is a packet, that packet TTL value is 64. Okay, this is a TTL value, initial TTL value of this packet is 64. Suppose this packets enter into the network and hit the router 1. When that packet hit the router 1, TTL value becomes 63. When it go to the router 2, go towards router 2, TTL value becomes 62. Okay, so TTL when it go to, and when that packet go to the router 3, TTL becomes 61, and when it go to the router 4, TTL value becomes 60. So meanwhile, this thing is also possible that from the router 4 again go to router 1, then router 2, 3, 4. So meanwhile, that simply means packets stuck in a loop. Okay, so that means meanwhile value becomes 0. It means when meanwhile stuck in a loop, the packet values become 0. That simply means data get lost. Okay, now when that TTL value becomes 0, so that simply means, you know, whatever that client sends to you is that packet data gets lost. Okay, because simply your packet stuck in a loop. Okay, and as I told you, TTL is just a notification of packet to check whether the packet is not in a loop. Okay, and but now here it's stuck in a loop. Okay, now to save this packet, the ICMP comes. Okay, to save this packet, save ICMP comes, and here ICMP stands for Internet Control Messaging Protocol. Okay, what this ICMP gonna do? And because this is a packet, and packet generally contains a source IP, destination IP, and IP header. Okay, so what this ICMP gonna do? This ICMP checks the source IP, checks SIP. Here SIP stands for source IP. Okay, and go to source, and tells the source that whatever you send is get dead, so again retransmit the data. So go to the source and tells retransmit the data. Okay, so that's why. Okay, but here now you understand this story, but here the thing is that you have to keep the TTL nature in your mind, that whenever a router or a hop come in between the journey, this TTL value decrease by 1. That's why here it is showing you 56, okay, instead of 64, because when I ping the google.com, so in between the journey there are different router or a hop. Okay, so that's why whenever the packet hit to the new hop, value decrease by 1. Okay, so meanwhile if you check out this stuff, I trace route this thing. So trace route google.com. So see, so 64 minus 7, it would be approximately it would be 56. Okay, get this? So that's why. Okay, and see, like suppose if I ping myself, so see TTL value 64, and yeah, right now I'm using the Linux operating system, but right now the value is not decreasing because obviously this request don't go to my router. Okay, that's why the value didn't decrease. Okay, so yeah, this is the first way of how to detect operating system with the TTL value. Okay, now let's move to the next thing, which is called the header. So with the header also you can detect the operating system. Okay, and how you're going to check the header? Right now for this thing I'm going to use via burpsuite. I'm going to use the burpsuite. Okay, so the first thing is TTL value. So TTL, you can go for the ping, and this you can go for the ping. And now with the header also you can detect the operating system. Okay, now but basically what is header? So what is header actually? Whenever you send some request to some server, and when that server send you the response, so in that request and response simply means that packet, when you open that packet, there is a very specific area which contains some informations like user agents, referral, cookies. Okay, so that particular area is called the header, and with the help of that header we can detect the operating system. Okay, so now let's see how. Okay, for this thing I'm going to use the burpsuite, and definitely, seriously guys, burpsuite is a very best tool. I mean, so desktop, and here's the burpsuite I have open in terminal. I can jump. Okay, but make sure you guys have the crack version of the burpsuite, otherwise in the community version it's not possible. Okay, I mean okay, so just next start burp. So just go to the, so if you guys are using first time this burpsuite, then make sure you can keep remember this thing. So okay, here the burpsuite start, but you have to learn about how to configure this burpsuite with your browser. So just open the settings, go to the advanced, go to this networks, then click on the settings, and here the proxy you have to set. So manual, you make sure this proxy is same for your burpsuite also, okay, and port number 8080. You can use any port, but make sure you have to define that same port in your burpsuite tool. Okay, so it is okay, done. Now I go to the burpsuite. Here it is. Go to the proxy, click on the options, and see it is the same, just like your browser's configurations. Okay, so make sure it is same. Okay, now what you have to do, just click on the intercept. Okay, first time I'm just making that intercept off, because whenever you're going to use the burpsuite, so the scenario is like this. Whenever you are going to use burpsuite, scenarios like this, like a client burpsuite and the web server. So that simply means whenever the client sends something to the web server, that thing first go to the burpsuite, then to the web server, and whenever web server sends something to the client, so it goes to the burpsuite first. Okay, so meanwhile through the burpsuite you can analyze that thing, that requests. Okay, now so for this thing I'm going to use a site called test.php1web. Okay, so it's open. Now I go to the burpsuite, go to target. So see, I go to the intercept. Okay, first I'm making the intercept on. I just reload this thing, and the request go to the burpsuite. So here it is. I'm just sending this thing to the spider. Okay, yes, then immediately off this intercept, otherwise can't be able to do this thing. So spider simply means check out all the stuff, whatever all the contents of that particular application. Simply means you can say that with the spider you can get the site map, okay, of the application. Now go to the target. Here's the test one web PHP, and you can see all the contents over here. Okay, and now if you like okay, let me first, yeah, it is already in the scope, because so I just click on this thing, show only scope in items, and here it is. If I click on anyone, then you will able to see that here it is showing me that it is Windows NT 64-bit. okay, and yeah, it's okay. So this is the second way of how to detect the operating system with the header part. Okay, so now I'm closing this thing. Yes, preferences, make sure just restore this stuff again. System proxy. Okay, okay, so this is the second way. Now the third way, we are going to with the nmap. So with the nmap also you can detect the operating system by using the either -a, or you can go for the -O also, and the IP. Okay, with this thing you can also detect the operating system. For example, okay, clear out the stuff. So nmap -A 192.168 R0 dot 100, and -A stands for the aggressive scan. Just putting some verbosity here. Let's see. So meanwhile it is running. So because nmap is a kind of tool generally used for gathering the information, but not just only for gathering the information. Sometimes I also use this thing for the vulnerability scanning, because nmap contains lots of scripts. So if you want to see it, because meanwhile it is running, the scan is running, let's see this thing also. So if you go to cd/user share/nmap/scripts ls-l, so these are all the scripts right now available. So let me see if there is a script for because there may be a script for the detecting the operating system. Okay, so I think that OS, okay, yeah, here it is, OS discovery script. So let's see this and we'll also see how the script thing works. So nmap -v for verbosity -script is equal to Ctrl+Shift+V, paste that script name and the IP 192.168.0.100 and enter. So see, just showing the same stuff like this. So see, here the result scripts now, and it is saying that it's the Windows 7 Ultimate. Okay, -PC, yeah, it is. Okay, so yeah, through that thing you can also detect the operating system. Yeah, so that script also show me the same result. Okay, yeah, here it is. No, it's that different one. Here it is. See? Okay, so this is the third one of detection of operating system. Now the last one we are going to do is called the port scanning. Because from the port scanning you can also detect the operating system, because see, different operating system have different ports at different time they opens. Okay, so that's why. So with the port scanning also you can do the same stuff. So okay, how can do this thing? So nmap right now, just simply by port scanning like this. Right now, -v tops port space 20 space 192.168.100. You see, some ports open like for the Microsoft DS. Obviously, Microsoft is only on the thing Microsoft. Okay. So with this the port scanning, you can also detect the operating system. And now there's another one which is called TCP window size. Through TCP window size, you can also detect the. Okay, so the last one we did is the port scanning. Port scanning by nmap, and the last one is called TCP window size. So this four are the sufficient for this thing. Okay, let me show you this thing also, but you know you have to work on this thing. It is just like this detailed stuff. Okay, so TCP window size simply means, because you know every operating system have TCP window size. It's a kind of like, you know, every operating system have different capacity to, you know, send or retrieve the data. Okay, it's a kind like, suppose if a client is on the Windows server, sorry, if a client is using the Windows machine and the server is on the Linux based machine, then maybe their buffers can vary. I mean, for sending and retrieving the data, the capacity can be vary. So that's why there is a buffer in between. Okay, so the same like this, you know, that thing belongs to the TCP window size. So you can check out that stuff with the Wireshark. Okay, just go to the Wireshark, because see, again I'm saying every operating system have different TCP window size. Okay, so you know, just, you know, go to the Wireshark. Yeah, here it is. Go to the capture options, manage interfaces, and make sure you enable that one through which you are connected right now. Just connected to the WLAN, enable that thing. Okay, and start, and see, now if I hit enter, so it start capturing. If you pick up a packet, and when I click on this one, so it shows me the calculated window size. Okay, so you have to, you know, compare that one with the list which you're gonna download from the Google, just by typing download TCP window size list of different operating system. Okay, and that's it. So these are the methods through which you can detect the operating system. Yeah, these are the ways through which you can detect the operating system. Okay, so now I'll see you on the next video, and in that next video we are going to do the footprinting. Okay, so this is all for the fingerprinting, and you guys, I think hope you guys will know that what is basically fingerprinting means. The OS detection, you have to detect the operating system. Okay, and you know, like you have different stuff also to cross check your informations. As I told you, reconnaissance is a kind of phase in which we gather the informations as much as possible must be confidential and true. Okay, so for checking out the stuff, like whatever information I get, is it true? So you can cross check it with other one. Okay, okay, so this is enough for this video. Okay, and the next video is about the footprinting. Okay, so I'll see you in the next video. Okay, bye.